In this section, what you'll notice is the problems are set up where you have ax squared, or you can rewrite the equation in the form ax squared equals c. In other words, your b term is a 0. What we can do is we can now solve for x in a different way. Besides factoring, what we can do is we can solve for x by isolating the squared term and taking the square root of both sides of the equation. What that means is, instead of, another word for isolating is, get the squared part by itself first. So if you look at this example down here, the original problem was 2x squared minus 14 equals 0. My goal is to first get the squared part of this problem by itself. I would do that by adding 14 to both sides, which will get me to 2x squared equals 14. I would then divide by 2, because 2 is not being squared, just the x's. That would get me to x squared is equal to 7. And then, to get rid of squared, to get from x squared to just x, I would square root both sides. And that will get me to x equals plus or minus the square root of 7. Again, the reason we have to use plus or minus on solving problems is because we introduce the square root to the problem. Simplifying, they introduce the square root. So if we look down here at the bottom, here's an example that is similar to this one. Right now, we're at 3x squared plus 5 equals 41. We are first going to get the squared part of this problem by itself. I'm going to first subtract 5 from both sides. That will get me to 3x squared equals 36. I am then going to divide both sides by 3, which will get me to x squared equals 12. And then to get from x squared to just x, my last step will be to square root, and that will get me to x is equal to plus or minus the square root of 12. The last thing you have to do is check to see if your answer will simplify at all. And the square root of 12 will actually simplify down to square root of 4 and the square root of 3. And so my final answer will be x equals plus or minus 2 times the square root of 3. If you look at example number 2, again, it doesn't matter if it's an expression that's squared. Our goal is to first get the squared part of this problem by itself. And so the part that I need to get rid of then is this 1/5. It is 1/5 times the squared part. So yes, you can divide by 1/5, but remember the better method than dividing by a fraction is to multiply by the reciprocal. And so I'm going to multiply both sides by 5 or 5/1. That will cancel that out, and I will just be left with x plus 3 squared on this side equal to 35. The nice thing is now the fraction is gone. Even though it's an expression, because that is the part that is squared, once we get the squared part by itself, you are going to square root both sides to undo the exponent. And that will get you to just x plus 3 on this side equal to plus or minus the square root of 35. Now, from here, again, check to see if 35 has any perfect square factors, which it does not. And so this is as simplified as this can get. Our goal here is to solve for x, though. The last thing you would need to do is you would need to subtract 3 from both sides. Here is really what you are doing. You have a negative 3 that you are going to add to the square root of 35, and you have a negative 3 that you are going to subtract from the square root of 35. Now, in this case, an integer and a radical are not like terms, and so we really can't solve these problems. You can either write them out separately, because this is really what the plus or minus sign means. It means I have a positive square root of 35 and a negative square root of 35. However, another way you may see these written, instead of writing it as two separate expressions, you may also see this as just x is equal to negative 3 plus or minus the square root of 35. Just as a rule, what you will notice is you will see most of your answers where the integer is first and then the radical is listed second.